What if the universe isn't just some, random cosmic accident? What if its very existence and its incredible order points to something more profound?
Exactly. And today, we're diving deep into these huge questions. We're looking at the cutting-edge discussions around the ultimate origins, the design of the universe.
Right. And we'll be exploring how these really ancient philosophical arguments, particularly the Kalam Cosmological Argument and the Teleological Argument, are actually getting a new lease on life.
They really are. They're being reevaluated, even strengthened, by modern scientific discoveries and some pretty deep conceptual analysis. It's fascinating stuff where old wisdom meets new science.
And our sources for this deep dive today, they come from a whole body of work by top academics, scientists, philosophers, people right in the thick of these debates, crossing disciplines.
Yeah, folks doing the hard thinking on this.
So our mission here is simple: to boil down the key insights, the most important bits of knowledge for you. Think of it as a shortcut to getting really well informed on something that, touches the very fabric of reality.
Get ready for some surprises, maybe a few aha moments along the way.
Okay, so kicking things off, many people just assume, don't they, that science alone has all the answers about where the universe ultimately came from.
That's a common view, yeah. But what's really striking is how indispensable philosophy actually is in this whole quest, even for the most advanced science.
How so?
Well, the cosmologist Sean Carroll pointed out this kind of disconnect. He said physicists often get baffled by philosophers focusing so much on the meaning of words. While philosophers get, let's say, exasperated by physicists using words without maybe fully grappling with their meaning, it shows there's a gap sometimes.
That makes a lot of sense because physics itself, it relies on logic, right?
Yeah.
Deductive, inductive reasoning.
Absolutely. And the justification for using that logic, that's philosophy. Think about basic logical laws like a shapeless square cannot exist.
Right. Self-evident almost.
It's known a priori. You don't need an experiment. You know it through reason alone. And these laws, they hold true everywhere. At the beginning of time, in the quantum world, doesn't matter.
So what does that tell us then about what's really fundamental?
It tells us that metaphysical considerations, questions about the fundamental nature of reality, are often more basic than purely mathematical ones. You could have a cosmological model that works mathematically, but if it's metaphysically impossible, if it violates fundamental logical principles, then it's just wrong.
Could you give an example?
Sure. Think about verificationism. That was the idea that only statements you can empirically verify are meaningful.
Right. I remember that from philosophy class.
Well, it's largely rejected now. Why? Because the principle itself cannot be empirically verified.
It fails its own test.
Exactly. So it shows that just equating factual with what I can test in a lab is a mistake. It kind of begs the question against anything like an immaterial, timeless creator who, by definition, wouldn't be empirically observable.
So, Stephen Hawking saying philosophy is dead. Maybe that was a bit premature.
I think so, yes, with all due respect. As the physicist Carlo Rovelli pointed out, philosophers offer crucial tools and skills. Things like conceptual analysis, spotting ambiguity, precision in language, finding gaps in arguments, even devising new ways to look at things.
Skills useful for science itself.
Essential for science. So no, philosophy isn't dead. It's vital if we want a complete picture of reality.
Okay, so with philosophy firmly back in the toolkit, let's tackle that huge question. Did the universe have a beginning? And this ancient argument, the Kalam Cosmological Argument, the KCA, how is it relevant now?
Right, the KCA. It's ancient, but its structure is really simple and powerful. Premise 1, whatever begins to exist has a cause.
Okay, seems intuitive.
Premise 2, the universe began to exist.
The controversial one, maybe?
That's where science comes in the conclusion. Therefore, the universe has a cause.
Simple structure. But that second premise, the universe began to exist, how does modern science weigh in?
Well, this is where it gets really interesting. The KCA isn't just some philosophical thought experiment anymore. Contemporary cosmology actually offers pretty strong support.
Like the Big Bang.
Exactly. The standard model of the Big Bang physicists call it the Friedmann-Lemaitre-Robertson-Walker model. It posits that matter, energy, space, and time itself literally came into existence at an initial point, a singularity.
Creation ex nihilo, out of nothing.
That's often how it's described, yes. And there's more. The Bordguth-Vilenkin theorem. the BGV theorem.
Okay, what's that?
It's a really significant result in cosmology. Basically, under very general conditions, it shows that any universe which has, on average, been expanding throughout its history cannot be infinite into the past. It must have a beginning. It puts a limit on how far you can rewind.
A cosmic no rewind past this point sign.
Sort of, yeah. And then there's Aaron Mall's work applying the generalized second law of thermodynamics.
Thermodynamics, that's about disorder increasing, right? Entropy.
That's the one. Wall's work suggests that even if you go back into the very early quantum gravity era, the principles of thermodynamics still point towards a beginning. The universe must have started in an incredibly ordered, low-entropy state.
So multiple lines of scientific evidence seem to point toward the beginning.
Increasingly so, yes. Far from disproving a beginning, modern cosmology seems to bolster that second premise of the KCA quite significantly.
But what about alternative models?
Yeah.
I've heard about things like bouncing universes or eternal inflation, models that try to avoid a singularity, avoid that absolute beginning.
Good question. Those models exist, certainly. Things like bounce cosmologies, eternal inflation scenarios, ekpyrotic models. But it's crucial to understand they are, for the most part, highly speculative.
Why speculative?
Primarily because we lack a well-established, tested theory of quantum gravity, which is what you'd need to accurately describe those very extreme early moments. Plus, many of these models run into serious problems. Well, many struggle with the thermodynamic issues we just mentioned, that requirement for very low initial entropy. The BGV theorem often still applies or requires special pleading to avoid. Some models face issues of inherent instability they wouldn't last.
And the eternal inflation idea, where new universes are constantly budding off.
That one faces huge problems too. There's the idea that in an infinite multiverse, anything that can happen will happen. But that relies on assuming an actual infinite future, which isn't proven. And worse, it leads to predictions that just don't match what we see.
So
It runs into something called the measure problem. If there's an actual infinity of universes, making predictions becomes almost impossible. It's far, far more probable in such a scenario to get, say, just a single brain floating in space having the illusion of our ordered universe a Boltzmann brain than our actual, vast, consistently ordered cosmos. Yet, we observe the latter. This suggests the premise of an actual infinite ensemble might be flawed. Max Tegmark, who used to champion these ideas, now calls the measure problem perhaps the greatest crisis facing modern physics.
wow. Okay, so the evidence for a beginning seems pretty robust, despite those speculative alternatives. Let's go back to the first premise of the KCA then. Whatever begins to exist has a cause. Does that hold up? Some might say, okay, maybe it applies within the universe, but does it apply to the universe itself?
That's the key objection, right? Does the causal principle apply universally? Well, think about the alternative. If things could genuinely pop into being, uncaused, out of absolute nothing, why don't we see it happening all the time?
Like, why doesn't a bicycle just appear in my living room?
Exactly, or a Beethoven symphony just start playing from nowhere. Nothingness, true absolute non-being, has no properties, it has no potential, no constraints. It couldn't be selective about what it produces.
So if anything could pop into being from nothing, we should see everything popping into being from nothing all the time.
Precisely. The universe would be a chaotic mess of things constantly appearing uncaused. Maybe electric fields just spontaneously increasing in strength for no reason. But that's not the world we live in. Our experience strongly confirms that things don't just spring into existence without a cause. This is sometimes framed as a modus tollens argument. If things could begin uncaused from nothing, we'd observe such events. We don't observe such events. Therefore, things don't begin uncaused from nothing.
Okay, that makes intuitive sense. But what about quantum mechanics? Doesn't that show events happening without causes, like radioactive decay or quantum fluctuations? Isn't that uncaused behavior?
That's a really common misconception. Quantum events are unpredictable or indeterministic, according to standard interpretations, but that's not the same as being uncaused.
Explain that difference.
Well, take quantum fluctuations in the vacuum. These particles don't emerge from absolute nothing. They emerge from the quantum vacuum, which is actually a sea of fluctuating energy fields governed by physical laws. It requires pre-existing fields and energy as necessary conditions.
So there's something there, not nothing.
Correct. And Heisenberg's uncertainty principle, it's about limits on measuring properties of a pre-existing system, like the energy over a time interval. It doesn't mean energy is being created from absolute non-being. Also, it's worth remembering that not all interpretations of quantum mechanics are indeterministic.
Oh.
Yeah, interpretations like David Bohm's pilot wave theory are fully deterministic. The apparent randomness might just be down to our ignorance of hidden variables, our epistemological limits, rather than genuine ontological causality or causelessness. So quantum mechanics doesn't really provide a loophole for something beginning uncaused from nothing.
Got it. So the causal principle seems solid. And the universe likely had a beginning. What about that infinite past idea again? Could there have been an infinite series of causes leading up to the universe's beginning, avoiding a first cause? An infinite regress.
The infinite regress problem. Philosophically, there are strong arguments against the possibility of an actual infinite number of past events.
Like this.
Well, one line of argument is about the impossibility of forming an actual infinite by successive addition. You can always add one more event, but you never reach an actual infinity. You can't traverse an infinite series to arrive at the present moment. Think about counting down all negative numbers to reach zero. Can you finish?
No, never.
Right. Similarly, you can't traverse an infinite number of past moments to reach now. And another angle is about causal dependence.
Okay.
Imagine an infinite chain of debtors. Each person in the chain needs to receive money from the person before them to pay their own debt. But let's say every single person in this infinite chain has zero capacity to originate money themselves. They can only pass it on.
Right.
Will the last person in the chain ever get paid, even if the chain is infinite?
No, because the money has to start somewhere. If everyone has zero capacity to start it, the whole chain has zero capacity.
Precisely. Now, apply that to causality. If every prior event in a causal chain is merely contingent, dependent on a prior event, and has no inherent power to begin existence itself, then even an infinite chain of such dependent events cannot explain how anything got started in the first place. The whole chain would have zero capacity to explain its own beginning.
So you need something at the start of the chain that isn't itself dependent in the same way.
Exactly. You need a first event, and by implication, a first cause that is not itself caused or dependent in that chain-like manner.
That's a powerful analogy.
Okay.
So the KCA seems to point strongly toward the first cause. Let's shift gears now to the other big argument, the teleological argument. This is the fine-tuning one, right?
Yes, often called the argument from fine-tuning or design. It focuses on the incredible, delicate balance we observe in the universe's fundamental features, a balance that seems necessary for life to exist.
What kind of features are we talking about?
Oh, things like the values of the fundamental constants of physics, the laws of nature themselves, the initial conditions of the universe near the Big Bang. Even tiny deviations in many of these would result in a universe radically different and utterly lifeless.
Can you give some examples? They're often mind-boggling.
They really are. Take the cosmological constant. It drives the accelerating expansion of the universe. Its value is incredibly, incredibly small. If it were significantly larger, maybe by factors ranging from 10 to the 50th power up to 10 to the 123rd.
That's a lot of zeros.
An unbelievable number. If it were that much larger, gravity would have been overwhelmed, and galaxies, stars, planets could never have formed. No structure, no life.
Wow. Any others?
The initial entropy of the universe at the Big Bang, it had to be extraordinarily low, meaning highly ordered. The odds against this specific low entropy state occurring by chance have been calculated as something like 1 in 10 raised to the power of 10 raised to the power of 123.
I can't even comprehend that number.
Nobody can, really. It's hyperastronomical. If the initial state had been more typical, higher entropy, the universe would likely have collapsed into black holes almost immediately, or resulted in just diffuse gas. No complexity, no possibility for life.
So it's not just that something improbable happened.
Exactly. That's the crucial point. It's not just improbability. It's specified improbability. The universe isn't just any old unlikely state. It's an unlikely state that also meets the specific complex requirements for permitting observers like us.
Like hitting a tiny target on a dartboard.
Yes, but it's more like drawing a tiny target first and then hitting it blindfolded from across the universe. The specificity is key. It's not just painting the target around wherever the arrow happened to land. The universe seems specified for life.
And beyond the constants, there's the mathematical nature of the laws themselves, isn't there? The orderliness.
Absolutely. The universe doesn't just have constants set right. It operates according to laws that are describable by incredibly precise, often elegant, mathematics.
But isn't maths just a human invention, a tool we use?
Well, yes, the language of mathematics is human. But the effectiveness of that language in describing the physical world, what Eugene Wigner called the unreasonable effectiveness of mathematics, is the mystery. Why does the universe obey these beautiful, subtle, mathematically sophisticated rules with such phenomenal precision?
Einstein wondered about that too, didn't he?
He did. He noted that the fact our mathematical theories work so well presupposes a high degree of order in the objective world itself, something you wouldn't necessarily expect a priori. It points to a deep, inherent rationality in the cosmos.
Are there philosophical views that try to address this? You mentioned mathematical structures earlier.
Yes, some philosophical positions, like certain forms of ontic structural realism, essentially propose that the universe is fundamentally just a mathematical structure. They try to eliminate concrete objects with intrinsic properties.
So reality is just math.
That's the idea, but it's metaphysically very problematic. Abstract objects, like mathematical equations, don't have causal powers. How could a mere structure make physical things behave in an orderly way? How do physical things causally interact if they're just relations in a structure? It doesn't seem to work as a fundamental explanation.
Okay, so we have this fine-tuning, this incredible mathematical order. If we're looking for the ultimate explanation, what are the logical possibilities?
Logically, when you consider the ultimate explanation for any contingent reality like our universe, especially its fine-tuning and order, the possibilities seem to fall into just a few exhaustive categories. You could say it's down to 1, chance; 2, regularity or necessity; 3, some combination of regularity and chance; 4, it's uncaused; or V, design.
Right, those seem to cover the bases. So how do these alternatives stack up against the data, against fine-tuning?
Well, let's look at them. Chance. As we saw with the constants and entropy, the probabilities are just so vanishingly small that invoking pure chance seems scientifically and philosophically untenable. It beggars belief.
Okay, so chance is out. What about regularity or necessity? Like maybe the laws had to be this way.
This hypothesis just pushes the question back. Why do mindless, non-intelligent physical laws and constants necessitate this specific life-permitting structure? How could purely physical necessity result in such specified complexity? And fundamentally, laws of physics are descriptions of how things behave. They aren't concrete entities that make things happen. So appealing to laws doesn't really explain their origin or fine-tuned nature.
All right. What about the combination regularity and chance? This is where the multiverse often comes in, right? Maybe there are countless universes generated by some underlying laws, regularity, and by chance ours just happen to have the right numbers.
Yes, that's the most popular alternative explanation offered today, the multiverse hypothesis.
Does it work?
Well, there are major problems. Firstly, there's currently no independent, verifiable evidence for these other universes proposed in atheistic scenarios. Models like Everett's many worlds or eternal inflation are highly speculative and, as we discussed, face significant theoretical hurdles.
Like the GSLT and the measure problem you mentioned.
Exactly. Many popular multiverse scenarios seem inconsistent with the generalized second law of thermodynamics, and the measure problem remains a huge thorn if you have an actual infinity of universes. Predicting anything becomes problematic, contradicting the success of physics in our observable universe. It's actually far more probable, statistically, for a multiverse to spit out minimally ordered universes, or Boltzmann brains, than a universe like ours that persists in complex order for billions of years.
So the multiverse doesn't necessarily save you from the improbability.
Not really. And even sophisticated underlying theories, like string theory, which was hoped to be a theory of everything that would predict the constants, well, it didn't. Instead, it predicts a vast landscape of maybe under 500 possible universes with different laws and constants.
So it doesn't explain our specific universe.
No, the landscape itself becomes part of the fine-tuning problem that needs explaining. Having a huge number of possible lottery tickets doesn't explain why your specific ticket won the life-permitting jackpot. It actually makes your specific win more surprising, not less.
Okay, so chance, regularity, combinations like the multiverse, and an uncaused physical universe, which the KCA argues against, all seem to face serious, maybe insurmountable problems when explaining fine-tuning and order.
That seems to be the case, yes, when you rigorously analyze the alternatives.
Design emerges as the most plausible remaining explanation in that list of 5.
It appears to be the most compelling ultimate explanation, yes.
But here comes the classic pushback, the one everyone asks. If the universe needs a designer because it's complex and ordered, then who designed the designer? Doesn't design just lead to an infinite regress of designers?
That's a very common objection, but it misunderstands the conclusion of the arguments. The arguments, particularly the KCA, conclude that the ultimate cause must be uncaused and beginningless.
Ah, so it doesn't begin to exist, unlike the universe.
Precisely. The first premise of the KCA is, whatever begins to exist has a cause. An uncaused, beginningless first cause doesn't fall under that premise. Its complexity, like having thoughts or knowledge, isn't the kind of organized complexity we see in physical objects that are composed of parts arranged in a specific way and which do have a beginning. So the first cause doesn't require a designer in the same way. It's the ultimate uncaused source of the contingent reality we observe.
Okay, that distinction is crucial. So based on both the KCA and the teleological argument, what properties can we logically infer about this first cause or designer?
Well, pulling the threads together from both arguments, we can infer quite a bit. First, as we just said, it must be uncaused and beginningless. It's the ultimate reality, not dependent on anything else for its existence.
Makes sense. What else?
It must be initially changeless, at least in the state, causally, prior to creating the universe. Why? Because if it were undergoing change, that change itself would be an event requiring a prior cause, leading back to the infinite regress problem. It exists in a state of causal priority before the first event, which is the beginning of the universe, and time itself.
Changeless, but it causes change. How does that work?
That implies it must possess what philosophers call libertarian freedom. That's the capacity for an agent to genuinely initiate a new causal chain, to choose to act without being determined by prior conditions. Think about it. How does a timeless, changeless reality give rise to a temporal, changing universe? The most plausible answer is a free choice. A freely chosen action by a conscious agent isn't an event caused by prior events in the same way physical events are. This implies the cause is a personal agent.
Okay, so uncaused, beginningless, initially changeless, free, personal.
Oh.
What else?
Well, the fine-tuning argument points strongly towards intelligence. Bringing about a universe with such specific constants, initial conditions, and elegant mathematical laws strongly suggests foresight and purpose, not blind chance or mindless necessity. Mindless entities just don't exhibit that kind of goal-directed, specified complexity.
Like presumably powerful.
Enormously powerful, yes. Even if you subscribe to theories like the zero-energy universe, where positive energy of matter is balanced by negative gravitational energy, the cause still needs immense power to arrange that energy, to bring the universe into being ex nihilo, and to establish the very laws of nature that govern it.
And separate from the universe.
Yes, transcendent. It must be distinct from the physical universe, space, and time that it brought into existence. It can't be part of the system it creates. So not something like Stephen Hawking's no-boundary proposal interpreted realistically, for example.
Okay, that's quite a list of attributes.
Yeah.
What about its relationship with time? You said initially changeless, causally prior. But doesn't a cause have to come before its effect in time?
That's how we experience causality within time, but it's not necessarily a universal requirement, especially when dealing with the origin of time itself. Think of it as an accidental generalization from our limited experience.
So how could a timeless cause create time?
There are philosophical models for this. One view, sometimes called the hybrid view, suggests the first cause exists timelessly, sans creation, without the universe, and then enters into time at the moment it creates the universe and brings out the first event. Its decision to create is timeless, but the effect marks the beginning of time.
So God exists timelessly and then enters time with creation.
That's one coherent model. Others, like the Oxford School, propose God exists in an undifferentiated, non-metric kind of duration timelessly, and then initiates metric time with creation. The key point is that for a superior being capable of timeless awareness and free decision, the sequence is logical priority, not necessarily temporal priority in the way we usually think of it.
Fascinating. One last thing. Why a single first cause? Could there be multiple uncaused causes?
It's logically possible, perhaps, but less plausible. Here's where a principle like Occam's razor comes in. Don't multiply explanatory entities beyond necessity. A single first cause is a simpler explanation than invoking multiple ones.
And the universe itself suggests unity.
Yes, the remarkable unity and consistency of the laws of nature across vast stretches of space and time strongly suggest a single unifying source rather than a committee of independent creators who somehow perfectly coordinated everything.
So putting it all together, the KCA and the teleological argument, when you really dig into them with modern science and philosophy?
They converge. They point towards an ultimate reality that is uncaused, beginningless, initially changeless, yet capable of initiating change, implying libertarian freedom and thus personality, intelligent, enormously powerful, transcendent, immaterial, and likely single, a creator of the universe.
Wow, what a deep dive that was. We've really journeyed through ancient philosophy, cutting-edge cosmology, the absolute mysteries of fine-tuning, the nature of time, and causality itself.
We have. And hopefully you, the listener, now have a much clearer grasp of how these arguments, sometimes written off as outdated, are actually very much alive, being rigorously debated and defended by thinkers today.
Absolutely. And this isn't just some abstract academic game, is it? Understanding these arguments, grappling with them, it can really shift how you perceive the universe, your place in it.
Definitely. It challenges us to think beyond just what we can touch and measure, to see the deep connections between logic, the nature of reality itself, metaphysics, and the physical world science describes.
So here's a final thought to leave you with. The universe, with its astonishing fine-tuning for life, its breathtaking mathematical elegance, its billions of spectacular stars and galaxies, maybe, just maybe, it's not the result of what Bertrand Russell called blind, pitiless indifference.
What profound implications might that have for your own quest for knowledge, for meaning in this vast cosmos? Something to ponder.